Good day, grade 12s. I hope you are fantastic. Welcome back to another exam revision lesson with Mr. T. And as always, I'll be sharing my approach to grade 12 maths, and I really hope that this lesson will be relatable and beneficial to you. And before we get into the lesson, perhaps just take a second to subscribe to the channel if you are new and press the like button, okay? Now, in today's lesson, we're going to be going over the November 2022 DBE mathematics exam, particularly question 5, okay? Let's begin. So as we usually do, I'm just going to read the information for us to understand what we are dealing with before we jump into the questions. If you're new to the channel, this is the procedure we always use. We start first by reading the information, then we read it at least twice, then we analyze the graph, then we get into the questions, okay? So I'm aware that there's a typo here, but I'm just going to correct it when I read that point, okay? So the information reads as follows. The graphs of g of x equal to 2x plus 6 and g negative prime, the inverse of g, are shown in the diagram below, right? And the first point says D and B, right, are the x and the y intercepts respectively of G, okay? I left out the y-intercept. It's just a typo. Let me read it again. D and B are the x-intercepts and the y-intercepts of G respectively, okay? And then the second point says C is the x-intercept of G negative prime, which is the inverse of G. Then it says the graphs of G and its inverse intersect at point A. Okay, so now let's read that one last time. Then we somewhere just analyze the graph as well. The graphs of G of x, where's G of x? Let's start to do our analysis. There's G of x over there, right? And its inverse, the inverse gonna be this one here, right? These graphs are drawn below, yes, and D and B are the x and the y-intercepts. That's the y-intercept of G, and this over here is going to be the x-intercept, okay? Right? Now, you already know for the y-intercept, we know that the x value is 0. For the x-intercept, we know that the y value is equal to 0, okay? Then they said C is the x-intercept of the G negative prime, the inverse of G. Yes, that's the x-intercept of the inverse. And then the graphs G and its inverse intersect at A. There is point A over there. They intersect at that point, right? What does it mean when they say they intersect at that point? It means that is the point of intersection. What happens at the point of intersection? G of x is going to be equal to its inverse at that point. Okay, I hope that makes perfect sense. Okay, at that point the two are equal. Okay, right, then let's read the first question. The first question says write down the y coordinate of B. Okay, the y coordinate of B is basically the y-intercept, because B is the y-intercept, right? So the y coordinate would be the y value of the y-intercept. How do we calculate the y-intercept? We said let x be 0, but for a straight line like this one, it's very simple. You don't have to calculate it. That's why they didn't say calculate. They said write. So you see the constant in the equation, which would be this guy here, is your y-intercept, is the y coordinate of the y-intercept. Okay, so you're just going to say y equals to 6. If you want, you can calculate it. Just say g of 0 equals to 2, open bracket 0 close, plus 6. This is going to give you 6. G of 0 equals to 6. I hope that makes perfect sense. Right. And then question 2 says determine the equation of the inverse in the form g negative prime x equals to mx plus n. Okay, so they want us to calculate the inverse. As you know, to calculate your inverse, you have to firstly look at the original equation, which is basically y equals to, or let's use g of x equals to 2x plus 6. But remember, your g of x represents the y, so we can do this. Just say y equals to, and then to move it to your inverse, right? This is going to be the inverse here. You swap the x and the y, okay? So this is what's going to happen. The x goes that side where the y was, and then the y comes over here. So it's going to be x equals to 2y plus 6. Then from here, as they have alluded, you have to make the y subject of the formula, okay? So first thing first, we're going to transpose the 6 to the other side. We're going to have x minus 6 equals to 2y. We divide everything by 2. Then our y, which is basically later, we'll change it later to g negative prime x, is going to be x over 2 minus 3. However, the x over 2, as you saw here, they said write it in the form mx. Mx meaning emphasize the coefficient of x. In this case, the coefficient is not emphasized. So x over 2, if we wanted to emphasize the coefficient, we can write it as 1 over 2x. It's the same thing. Okay, so then we're going to say 1 over 2x minus 3. Then we change the y to the inverse. We can say g of negative x, negative 1x. There we go. If you want, you can write it from left to right. It's just in this case, I'm kind of forced to write it from right to left. Then I can take this, bring it over here. There we go. Write it exactly how they asked me to. And just like that, I've calculated the inverse of g of x. Okay, so the first step is always to swap your x and y, right? And then you simplify by making the y subject of the formula. Then the y becomes the inverse. Okay, I hope that makes perfect sense. All right, and then let's proceed. Let me just quickly do this. There we go. Question 3 says determine the coordinates of A. Okay, determine the coordinates of A. How can we determine the coordinates of A? A is the point of intersection, like we said, so we just have to calculate them, equate our g of x and the inverse. The g of x is 2x plus 6. Our inverse is half x minus 3. Right, we equate them, then we group them, take the half x to this side. We're solving for x now. Bring it this side, it's going to give us half x equals to negative 3. Take the 6 minus 6, it's going to give us negative 9. Then this is going to be 3 over 2x. We divide both sides by 3 over 2. 3 over 2, this cancels that. Our x is going to be negative 6. Meaning, as far as the coordinates of A go, the x is negative 6. We just have to figure out the y coordinate. How do we figure out the y coordinate? We take the x coordinate, we substitute it into any one of the two equations, either the g of x or the inverse. Okay, so we're going to start with the g of x. I'm going to say g of negative 6 equals to, then we say 2 open bracket negative 6 plus 6. This is going to give us negative 6, right? If you want, you can also use the inverse. It's going to give you the same answer. Half 6 minus 3. It will also give you negative 6. And just like that, you can conclude that your y value is negative 6. Are we clear? Then the coordinates of A will be negative 6 and 6. Okay? You can use any one of the two equations to find your y coordinate. Okay? Then question 4 says calculate the length of AB. Calculate the length of AB, right? So we come to the graph, look at the graph, AB is a diagonal line, right? It's not vertical or horizontal. It moves diagonally. Okay, so it means that we have to use the distance formula. So we can say, okay, distance formula AB equals to the square root of the x of A minus the x of B squared plus the y of A minus the y of B squared. Then we can just substitute everything here. Our x of A is negative 6 minus x of B, that's the y-intercept, the x is 0, then you say squared minus, plus I meant to say, open bracket, negative 6. The y of B is what? It's 6. So you put 6 there, squared. This is going to give us what? 36 plus 144. And then gives us square root of 180. You can simplify this and say 6 root 5. I hope that makes sense. Okay, if you want to write it as a decimal, it's going to be 13.42. Okay, so we are now done with this question. Whenever they say calculate the distance, you can just use the distance formula like I did here. Okay, you'll always get the correct answer. And when they say calculate the point of intersection, like they did with the previous question, calculate the coordinates of A. If it's a point of intersection, you equate the two equations. Okay, G and G negative prime. Okay, then you find the x. From the x, you can substitute the value into any one of the two equations to get your y value. Are we clear? Perfect. Then we go over to the last question. The last question is the area formula. Okay, so they want us to calculate the area of triangle ABC. So there is triangle ABC, joins here, over there. There we go. Now, as you can tell, ABC is not a what is this? It's not a right-angled triangle, right? If anything, it's an isosceles triangle, right? But we will work that out in a minute. So we've already calculated the length of side AB. We said the square root of 180, right? So since it's not a right-angled triangle, it means we can't use the standard area formula. We can't use the half base times height, right? Because this one requires the perpendicular height of the triangle. But what can we use? We can use the area formula from trigonometry. Okay, so we'll say half of AB, right, times AC, right, sine of angle BAC. There we go. This angle over here. Do you understand? So which sides did we go with? We took this side here and then took that angle there and this. Remember, to apply your area rule, what do you need? You need side, angle, side. Okay, we already have we already have the length of side AB. We just need to work out the length of side AC and that angle over there. Okay, so let's maybe work out the length of side AC before we can get to the angle. So we're gonna say AC equals to, right, again it's the distance formula. So we can start with the x coordinate of A. It's going to be negative 6 minus do we have the x coordinate of C? No, we don't, so we would have to work it out. Perhaps let's work it out before we do this. So we'll say the x intercept of C, so the y is going to be 0, right? We're trying to work out the x intercept of C. Okay, 0 equals to 1 over 2x minus 3. You transpose the 3 to the other side, it gives you that half x can divide both sides by this. This cancels that. X equals 2. It's going to give you 6. Now, these calculations were not necessary. Why do I say so? It's because if you have the y-intercept of the original function of g of x, you can easily find the x-intercept of the inverse of g, right? So the y-intercept of the original of g of x is the x-intercept of the inverse. What do I mean by this? Look at this. The y-intercept was 0 and 6. The x-intercept of c is what? Is 6 and 0. All you do is you swap them around. Remember, when you move from a function to its inverse, you just swap the x and the y. That happens with all the points on the graph. Any point. So if I had 2 and 4, the inverse of this would be 4 and 2. Meaning the y-intercept of the original becomes the x-intercept of the inverse, and the x-intercept of the original becomes the y-intercept of the inverse. So I didn't have to calculate it, but I wanted to prove to you that this rule works. Okay, so the coordinates of c are then 6 and 0. There we go. I'm just going to quickly erase here. All right, so now we have calculated our x value for c. Then we're going to calculate the length of AC. It's going to be square root of -6 minus 6 close bracket squared plus -6 again. The y value is what? Is going to give us 0. There we go. Squared. This is going to give us 144 plus 3, 6, which gives us square root of 180. Okay, that's our AC. So clearly AC is equal to AB, right? So you're going to say this is square root of 180. There we go. Now we just have to work out the value of angle A. How are we going to do that? We're going to use the angle of inclination, right? So let me just do this to clean this up. So when you look at it's going to be difficult, you know, to directly get this angle, but we can take a longer route that would lead us to getting that angle. What would that be? If we can get the angle of inclination of AB, so we're going to say tan of angle BDC, for example, BDC, yes, is equal to, we get the gradient of, what's the gradient of ADB? Is 2, right? So we are trying to get this angle, but what's the goal with that? Someone is probably just wondering, but say, what is the goal with that, right? So the goal is, if I can get this here, right, and get this, or perhaps just get that, then I can say this angle over here is vertically opposite to this one, right? Which then I can use the exterior angle, which would be this, of a triangle is equal to the sum of the two opposite interior angles of a triangle, which would be this angle and that one. So then I will only have one unknown, which is angle BAC. Because the angle C, I'm going to find it using the angle of inclination as well. Angle D, I'm going to find it using the angle of inclination. So ultimately, my unknown is going to be at angle A. Okay, I hope that makes perfect sense. Now let's get to it. So let's find BDC first. We're going to then say angle BDC goes to tan there we go. Then this is going to give us, you put this in your calculator, put that in your calculator over there, gives you 63.43, right, degrees. Then we can move over to getting angle B, ACD or DCA. So you're going to say angle DCA, right? Which is this one. I'm using its letters because it's equal to the angle of inclination on the other side, right? So I don't have to figure out what are the letters for the actual angle of inclination, okay? Because they're more or less the same. This is also the angle of inclination of AC, because the two angles are equal to each other, okay? So then I'm going to say equals to dCA. What is the gradient of the inverse? It's going to be 1 over 2. Then we say dCA is equal to tan negative prime 1 over 2. This is going to be equal to, you do that, there we go, gives you 26.56 degrees. There we go. Right now I have the two angles, angle D and angle C. Then I can say, okay, angle B DC is equal to angle DCA plus angle BAC. Okay, this is 63.43 equals to 26.56 plus BAC. I transpose the 26.56 to the other side. It's going to give me 63.43 minus 26.56. That's going to give me 36.87. That's my BAC. Okay. Now that I have this, I can then use this formula here. I can use that. There we go. Okay, so I'm going to say the area rule, area of triangle ABC equals to half, open bracket, square root of 180, close another square root of 180, close, sine of, what's our angle? 36, open bracket, 36.87, close bracket. Then this will give us half, open bracket, square root of 180, close open, square root of 180, close, sine of 36.87, close bracket. This is going to give us 54.00. That's the area for this triangle. Okay, so I hope that you understand. I think this approach, there's various methods that I could have used, but this particular one, I found it a bit easy and relatable. I think that the concepts they used here is concepts that most grade 12s really understand, so it should make sense. Okay, if it doesn't, you can always leave a comment down below, and then I'll try to get back to you as soon as I can. Okay, I think this is the last question, and yeah, till I see you guys again, bye.